Welcome to Summarize Science, where we dive into the latest breakthroughs in technology. Today, we are looking at a new framework called HATS, which stands for Hardness-Aware Trajectory Synthesis. This system is designed to make AI agents much better at navigating phone apps and websites. You might have seen AI agents that can book a flight or change your settings, but they often struggle with complex tasks. The researchers identified a major hurdle they call the Semantic-Ambiguity Gap. This gap exists because AI often gets confused by things like a plus button that does different things depending on the screen you are on. Most existing training data is filled with simple, obvious actions that do not help an AI learn to handle these tricky situations. To fix this, the HATS framework changes how we collect training data for these agents. Instead of just wandering around an app randomly, the system specifically hunts for interactions that are difficult to interpret. This is called hardness-driven exploration, and it ensures the AI learns from the most informative examples. But finding hard tasks is only half the battle. The AI also needs to describe what it is doing with perfect accuracy. Often, the instructions an AI generates for itself do not perfectly match the actions it actually takes on the screen. To solve this mismatch, HATS introduces an alignment-guided refinement module. This module works like a teacher checking a student's work over multiple rounds. If the instruction and the execution do not line up, the system revises the text until they are perfectly aligned. These two parts work together in a closed-loop system to create a high-quality dataset. The researchers used a technique called Monte Carlo tree search to efficiently navigate through all the possible actions in an app. This process transforms vague or incorrect instructions into precise, executable guides. The results of this new approach were quite impressive when tested on major industry benchmarks. On a platform called Android World, the AI trained with HATS performed 100% better than previous leading models. On Web Arena, which tests complex web navigation, the performance jump was even more dramatic at 215%. By focusing on hardness, the system shifted its training to prioritize complex productivity and work-related tasks. This redistributed the training focus away from easy tasks that AI already knows how to do. This smarter training method leads to agents that are much more robust and less likely to fail in the real world. In one example, we can see how the system refined a simple calendar instruction into a detailed, step-by-step plan. This level of detail is exactly what an AI needs to reliably perform tasks in messy, real-world digital environments. It proves that focusing on the most difficult interactions is the key to creating smarter digital assistants. To recap, the HATS framework solves the problem of unreliable AI training data by focusing on ambiguity. It uses a closed loop to hunt for hard tasks and then double-checks its own work for perfect alignment. In the future, this could lead to digital assistants that can handle almost any complex app task you throw at them. Imagine an AI that never gets confused by similar-looking icons or tricky multi-step workflows. Thanks for watching Summarize Science, and stay tuned for more fascinating updates from the world of science.